In chapter 1, we talk about physical quantities. In the next chapter, measurement techniques, we will be talking about the quality of our measurements when measurements are taken of a physical quantity. Before we begin, do note that until 2021, this chapter is taught as a separate chapter. However, from 2022 onwards, this chapter is now combined with chapter 1, which is physical quantities. The change is really just a grouping change. There has been no actual change in the contents. All measurements are subject to errors, namely systematic and random errors. Systematic errors produce readings that are always either above or below the true value. For example, we have a pen whose length has a true value of 15.8 centimeter. We use a ruler to make repeated measurements of the length, giving us results set 1, set 2, and set 3. We would say that the first two sets of readings have systematic error, whereas the last set has no systematic error. Why do we say so? If we were to look at the first set of readings, 15.1, 15.3, 14.8, 15.6, and 15.0, these have values that are below the true value. So over here, all readings are below the true value. So by definition, this is systematic error. For the next set of readings, 15.9, 16.3, 16.0, 16.5, and 16.2, these values are all above the true value. So over here, all readings are above the true value. So again, by definition, this is systematic error. If we were to look at the last set of readings, 15.5 and 14.9 are below the true value, whereas 15.9, 16.3, and 16.0 are above the true value. So over here, we have a mixture of readings that are above and below the true value. So by definition, this cannot be systematic error, because systematic error must have readings that are either above or below the true value. Systematic error can also be thought of as a measure of how skewed the readings are from the true value. The larger the degree of skewing, or in other words, the further away the readings are from the true value, the larger the systematic error. If you consider the diagram below for systematic error, this dotted line here represents the true value, whereas this group of readings here represent the measurements that have been taken. Notice that they are all on one side of the true value or skewed towards one side of the true value. If these readings were shifted even more towards the left or skewed even more towards the left, we would have said that the systematic error has increased. Systematic errors are caused by poor experimental techniques, which is mainly attributed to the experimental's fault. Systematic errors are caused by zero errors of your instrument, or faulty equipment, or unsuitable laboratory conditions. When talking about zero errors, take for example an ammeter that is used to measure current. If that ammeter is taken off a circuit, there's no current flowing through the ammeter, so you will expect the pointer needle to go back to zero. However, in some cases, you might see that the pointer needle doesn't go back to 0, it maintains at some non-zero value. This is what we mean by zero error. You're not getting a 0 reading when you're supposed to, or in other words, you're getting a non-zero reading when you are not supposed to. Systematic errors are also caused by parallax errors. However, do note that systematic errors caused by parallax errors only occur if the readings are made from the same angle by the same observer. What do I mean by that? Take for example, when you're taking volume measurements from a burette. The correct way to take a reading will be at the meniscus level. However, because your burette is a very long pipe and is often mounted high above the bench, you will normally end up reading from the burette above the meniscus or below the meniscus, which in turn causes you to have parallax error. This would then lead you to have readings that are above or below your true value. If it's always the same person taking the reading at roughly the same angle, you will always get a reading that is below the true value. However, if you have two different persons taking the readings at two different angles, you will end up having a mixture of readings that are above and below the true value. So you will not be getting systematic error in this case. Lastly, do note that systematic errors can be eliminated but cannot be reduced. Taking the average of repeated readings will not reduce systematic error. To eliminate systematic error such as zero error, you will need to subtract the zero error from the measured reading. Referring to an earlier example where we talk about making repeated measurements for the length of a pen, we had these three sets of readings. We said that the first set of readings had systematic error because all the values were below the true value, whereas the second set of reading also had systematic error because all the values were above the true value. However, the last set of readings had no systematic error because it consisted of a mixture of values above and below the true value. Now, looking at the values for each set, notice that none of them are the same with each other. They have a degree of scattering, or there's a range to the values. This is what we mean by random errors. Random errors produce a scatter of readings about a mean value. If you see that there's a range to the readings, then it is confirmed to have random error. So these three sets of readings have random error right now. When we say mean value here does not necessarily mean the true value. Looking at the average values for the three set of readings, the first set had 15.2, second set 16.2, and the last set 15.7. Only the last set had the mean value close to the true value, whereas the first two sets did not have values that were close to the true value. So bear in mind here now that mean value would not necessarily be the true value. In general, the larger the degree of scattering of your readings, or the larger the range of your readings, the larger the random error. Looking at the two examples here, the first example has random error because you see that there is a scatter of the readings. The second example also has random error because you also see a scatter of the readings. Although over here we say that there is systematic error, it's also correct to say that there is also random error. You could have cases where your readings have a combination of both systematic and random error. Now, if your scattering increases like this, where your readings are all the way until here, we would have said that your scatter has increased. Therefore, your random error increases. Causes of random error could include fluctuations in external conditions such as temperature or pressure. Take for example the pen. If the pen was made out of metal, when temperature increased, the length would increase because the metal expands. Conversely, when the temperature drops, the length would decrease because the metal contracts. So, if we are making measurements when the temperatures are fluctuating, we would be getting a different reading each time. So we now have random error. Another cause of random error is the inability of an observer to measure small intervals or to repeat his actions precisely. This is caused mainly by human limitations, such as human reaction time. Take for example, when we're timing the oscillation of a pendulum bob. We would displace the pendulum bob to one side and let it oscillate. If we were using a stopwatch to time the oscillation, how sure are we that we will be stopping the stopwatch at exactly the end of the oscillation? A lot of times, we will end up stopping the stopwatch slightly before the end of the oscillation or slightly after the end of the oscillation. Moreover, if we were to try and repeat this timing again, we would not be able to stop at exactly the same point as before. This is what we mean by inability to repeat actions precisely. The last cause of random error could be parallax errors, but provided that the readings are made at different angles by different observers. Earlier, we said that systematic error can be caused by parallax error if it's always made by the same observer at roughly the same angle. However, if the readings are now taken at different angles by different observers, we would now have readings that are always above and below the true value. So we now have random error, not systematic error. Lastly, random errors can never be eliminated, but it can be reduced. This is in direct opposite to systematic errors. Taking the average of repeated readings here would actually reduce random error.